Hello, everyone. My name is Vaibhav Govill. I'm a senior product manager in Google. So thanks for joining in. Today, we are going to speak about Cloud Spanner. So we have a full-packed agenda today. So first and foremost, I'm going to introduce Cloud Spanner to you. What is Cloud Spanner and what are the capabilities which exactly differentiates Cloud Spanner? Then we are going to talk about some of the capability highlights. Finally, why customers are building on Cloud Spanner. We are going to discuss some of the use cases, solution architectures, depending on what customers are building on Spanner. And then we will end with some discussion around how customers are migrating to Cloud Spanner and what are some of the things to watch out for when that migration is being done. So let's start with the introduction of Spanner. So Spanner is a very differentiated product, means it is basically a database service which marries all the relational semantics with horizontal scale. So horizontal scale is something which you will expect from non-relational databases. This is about automatically sharding and horizontally scaling the database. So Spanner is infinitely scalable, and along with all this, it comes with an extremely high SLA, 5 nines of SLA. And with relational semantics, you get complete schema support, ACID transactions, SQL support, both DDL, DML, and everything. Spanner as a product has been battle tested by Google for quite some time. Means we have a number of Google products which are using Spanner today. Typically, when you are working with a database service, you are faced with these questions. Should you focus on performance, scale? Does your database have SQL capabilities or not? What about manageability? And I think the reason we created Spanner as Google is, why can't we have it all? Is you should have a database which can be very performant, it can scale infinitely, it provides you with complete SQL semantics, and gives you the complete managed experience as well. So this is what we strive to deliver all the time, and how we are able to do it, that's what we are going to talk today. So let's talk about the manageability aspects first about Spanner. So when we say Spanner is managed, we are saying it's fully managed plus experience, which we enable for our customers. Typically, if you are using a relational database service, you have to set up a primary replica, and then along with that, in HA replica, you have to pay extra dollars and extra setup for that, and then additional money for a read replica. All that costs you extra management overhead, extra money. Versus in Cloud Spanner, you buy a Spanner node, you get all of that inbuilt into the Spanner system, depending on the configuration which you are using. It's extremely simple. It's literally a single click for you to provision a Spanner database. We are talking about very good, simple administration. We provide a global endpoint, so automatic failure recovery. Spanner does automatic sharding. Basically, we shard based on 2 characteristics, which is load-based sharding as well as size-based sharding. It's done automatically for you, so you don't have to worry about it. And behind the scenes, there's easy global replication, which is done, again, depending on the instance configuration which you are choosing. Now, let's talk about the distribution nature of Spanner. So Spanner is a distributed relational database service, but we continue to offer that strong external consistency. And what do we mean by that, strong external consistency? Basically, we are talking about a relational database which offers you infinite scale, but it functions exactly like a single node Postgres or MySQL database. It's just that it can scale infinitely. It has the same consistency characteristics which you get from a single big box MySQL or PG database, with strict linearizability and strong consistency guarantees. How we are able to do that is the picture on the right on the slide, as you can see, is a photograph of an actual Spanner server, which is in our data centers. We have something called as true time. Basically, we have a global notion of time in which the clock skew between our data centers is extremely minimal. I'm talking milliseconds here. And all our span servers have this atomic and GPS clocks based on which we are able to sync the time. And based on the Spanner paper, which was written in 2012, as you will read it, we have that common global notion of time. So even if your database is spread across thousands of machines and nodes, we still are able to do a transaction across them and commit them. In terms of scale, we are talking about petabyte plus size single databases, which are operating on Spanner today, millions of QPS with consistent performance. I already talked about the distributed processing, but when we are talking about scale, one other thing to highlight is Spanner has complete separation of storage and compute. So this diagram on the lower right corner of the slide, you will see these are the compute nodes which are there, and the storage is completely separate. The storage is actually in the Colossus layer. So what it enables us to do from a scaling perspective is if you are adding more nodes to your Spanner instance, basically the data is not being removed or copied or anything. Data stays where it is in the Colossus layer. Only the metadata is repartitioned and it's being resplit amongst the span servers or the compute nodes which are there. So again, extremely scalable from that perspective. And then finally, we have cell level concurrency control. Again, to enable that kind of petabyte plus size scale, as well as millions of QPS. Now, how does cell level concurrency control help? Is if you can imagine a table which has rows and columns, and you are doing a transaction, so you have to hold a lock. And in terms of that lock, you don't have to hold the lock for the entire row. We just hold it on a particular cell. And based off of that, the transactions happen. So again, extremely scalable from that perspective. So you can have multiple transactions going on within the same table, within the same item, because we have cell level concurrency control. Moving on, as I mentioned previously, we have one of the highest availability, which we offer for a relational database. Now, in case of regional instances, we offer 4 nines of availability. And we promise you 0 RPO, 0 RTO in case of a zonal failure. And how we are able to do that? So let's look at the diagram on the right. So this is a pictorial representation of a regional instance. As you can see, there are 3 zones in a particular Spanner instance. Within each of the zones, the data is automatically sharded, or what we internally refer to as splits. And there's the same copy of the data in each of the zones. So there are basically 3 copies of data. When you buy a single Spanner node, you get automatically, transparently, you get these 3 compute instances and 3 copies of the data behind the scenes. And we run a Paxos protocol. So basically, it's a Paxos group. One of those 3 splits in one of those 3 zones is going to be the leader. The blue ones represent the leader. And this is called as the Paxos leader. And basically, that is the one which holds the latest and the greatest data in terms of when you are doing the writes. So whenever a write is done, minimum 2 out of the 3 splits have to commit the write before we can give you a 200 OK. So just in case there's a zonal failure, that means at least one other zone in your regional instance would have the latest data. So hence the 0 RPO and 0 RTO from that perspective. There's no concept of planned maintenance or anything like that. 0 downtime for planned maintenance. We roll the binary changes behind the scenes. You don't even know about it. And even the schema changes. So let's say you have to add an index or do something else. It's completely done online, and you don't have to take a downtime for that, which is really nice if you're running mission critical applications which cannot afford any downtime. And the reason we are able to do that is Spanner has multi-version concurrency control architecture. So utilizing that, we are able to deliver on completely online schema changes. Now let's talk about this another picture. So this is about a multi-regional instance. In case of multi-regional, we offer you an additional 9 of availability. So 5 nines of availability is offered for a multi-regional instance. And our RPO, RTO guarantees are, in addition to a zonal failure, even a full region, just in case, and rarely it would have ever happened, but just in case if there's a regional failure, we give you 0 RPO and 0 RTO protection for that. Again, no maintenance windows, online schema changes in there. But more importantly, if you look at the diagram on the right, which is the representation of a multi-regional instance, there's a concept of a write quorum. And a write quorum is composed of 3 regions with minimum 5 replicas. And within this, as you will see, there's a default leader, and then there's a secondary region, US region 2. This is just one of the many multi-regional Spanner instances which we have taken on as an example over here. And in this case, whenever a write has to happen, again, there are in total, there are 9 replicas in this configuration. But within this write quorum, only these 5 replicas will participate in the write, and majority quorum have to be achieved. The rest are read-only replicas. And in this, all these 5 replicas, which is 4 read-write replica and the witness replica, are going to vote on the write. And till we get a majority, which is 3 out of 5, we don't commit the write. So basically, that is what gives you that protection against a complete region failure, because if you do any kind of permutation combination, the write is not committed until at least the data is being persisted in two of the 3 regions which are formed of write quorum. So hence that protection with 0 RPO, 0 RTO. With read-only replicas, you can get low latency reads. You have the option to do strongly consistent read. In that case, the read-only replica has to consult the leader replica in the write quorum. Or you can do, it's just a ping, by the way. It's not like the complete data is extracted from the leader. It's just a ping to make sure that the read-only replica has the latest data which is there. And it can also do stale reads. Okay, so since Spanner is an enterprise database, you can rest be assured we have all the security and compliance which you will expect from an enterprise database service. We offer a number of data protection capabilities. Spanner SQL is ANSI SQL compliant, and we offer a very easy to use, simple startup experience on Spanner. Now let's talk about some of the capabilities or the features which Spanner is offering. So here we have bucketed the features in these 4 categories, which is enterprise relational features, programmability, security, monitoring, and introspections. All key areas where you as a user are really trying to, as you build your workloads, utilizing Spanner, you are looking for capabilities in that. In terms of enterprise capabilities, we have all the data protection features, including managed backup restore. We recently launched point-in-time recovery. I'm going to talk more in detail later on in the presentation about this. In terms of programmability, we have 8 languages client drivers. We have a number of ORMs. Hibernate Spring Data, we just launched Django and beta. We continue to add more ORMs, including Enterprise.NET ORM and some others which will be coming. We have foreign key support. We have a completely offline local emulator. You don't have to pay anything for using this local emulator. It basically emulates Spanner APIs and Spanner SQL, and you can just do offline development with that. And when you're ready to promote your application in production, you can just push it on. So this is a very nifty way for you to do development without paying anything. And then we have a whole query optimizer, and we launched query optimizer versioning control and everything. In terms of security, we have all the compliance certifications which you can hope for, like in terms of PCI, SOC compliance, FedRAMP. We have VPC-SC support, access transparency, which is where GCP really differentiates itself, that if a GCP person or a SRE has to even touch your data for whatever reason, let's say there's a hurricane going to strike a particular data center and they have to touch the database to move it to some other data center, they have to log that request. That's what access transparency is. In addition to we recently added access approval support for Spanner as well. And then most recently, we launched customer managed encryption keys. So we are going to talk more about that later. And then we continue to invest in our monitoring and introspection capabilities. As you can see, we have open sensors integration, stack driver, we have a whole bunch of CPU utilization graph. And we continue to add more and more introspection capabilities in terms of information schema tables. So sys tables, which are like query, read, and transaction statistics tables, which are now there for you to evaluate how your database has been doing in terms of query performance and transaction performance. So as I mentioned, we just launched point-in-time recovery. Is an extremely flexible and very much requested feature. So the way point-in-time recovery works is, as I mentioned previously, Spanner has multi-version concurrency control, which is, you can envision as we will maintain a version control of every change for every key which you do, including schema changes. So that version control had a default retention window of 1 hour. That's how you can do stale queries. Now with PITR, you can change that version retention window from default 1 hour to all the way up to 7 days. And then you can use your stale read API, and the same thing which you use today, to query for a portion of the data, which can be based on a specific condition, a particular table, or the whole entire database at a point in time in the past within that version retention window. You can also create a consistent backup at a point in time in the past using the Managed Backups API, or you can create and export a data at a point in time in the past using the data flow export capability we have. So extremely flexible. So depending on your use case, if you know that you are running a SaaS application and only one particular customer's data got corrupted for whatever reason, you can just prepare a query for that particular customer's data in the past, get that data, and then update it on the current database, really improving your RTO time from that perspective. So very flexible. This is the other thing which we launched like end of March, customer managed encryption keys. This is primarily a key request from a lot of our regulatory industry customers. As you know, not just in Spanner, but all data in GCP is by default encrypted using Google managed keys. But in this case, customers want to control that key, and we are offering that control through Cloud KMS. And basically all data at rest at the time of database creation, you can pick a key, which is a Cloud KMS key at the time of database creation, and that key would be used for encrypting your database. And you have the flexibility to choose a different key for your backups. Again, all the typical stuff which you can expect, like keys can be rotated, you can disable those keys to control access to the data and everything. The other good thing is you can actually see that the encryption is working by enabling Cloud KMS API, audit logging on the Cloud KMS API. And then in the log viewer, you can see all the pings which even Spanner has made when it has to use that key to basically decrypt the data and all that kind of stuff. And Cloud HSM support is also there. And so, as you know, Cloud KMS provides software keys as well as hardware security module keys. HSM support is available for all regional instances and for select multi-regional instances. Same thing for KMS. For all regional instances, and software protected key support is available for select multi-regional instances. Okay, let's look at Spanner's footprint. So Spanner is available in all GCP regions. Most recently, we actually launched in Warsaw. Warsaw is a new region which was launched by GCP recently, and Spanner support is there. So we intend to maintain this. So Spanner will continue to be rolled out as the new regions are launching. In terms of multi-regional configurations, means we have 3 flavors of multi-region, 5 replica configuration, 7 replica, and 9 replica configuration. The example which I earlier showed was about this NAM UR Asia 1, the 9 replica configuration. Again, there are 13 total multi-regions. We offer this 99.999% uptime SLA. So again, the key difference between 5, 7, and 9 is just the number of read-only replicas. And you can see we have a whole suite of options which are available. We have a multi-regional option in Asia, which is Asia 1, is completely Asia-only multi-region. And then we have some intercontinental multi-regions like NAMU or Asia 1, which is North America, Europe, and Asia. Okay, so now let's talk about why customers are building on Spanner to begin with. So first and foremost, these are the business challenges which are faced by customers. First one is the capital expense. You don't want to be paying for fixed infrastructure just to handle seasonal peaks. If you are a retailer, if you are a financial company, it's bound to happen that some days are busier than others. In case of North America, we have Black Friday, Cyber Monday sale, and the peaks we have seen as 1,000% increase in terms of traffic. So you don't want to, you want a service which is a pay-as-you-go service, so it's economical for use. Korea in this case has built a lot of services and has great presence. Global presence in case of customers is very common. So it's very much possible that you have a global customer base. You want to provide the best experience possible for your customers. And that's why you need a multi-regional presence. And that means more cost, more infrastructure. Again, Spanner offers that. You don't have to spend the money to get that fixed infrastructure. And then operational cost means Spanner is a completely managed service. It requires a lot, as you would know, if you have managed like a Cassandra deployment or any of that. It takes a lot to maintain that high availability and high uptime and keep the lights on, as we say it. So, and operational cost is exacerbated with seasonal scaling. Now let's talk about some of the technical challenges which customers have informed us. Means I was talking about availability. You need that high availability. You want to have that DR options along with that so you can maintain high business continuity. We are going to talk about some of the use cases later on in the presentation where a single minute of downtime means millions of dollars. Scale, we have spoken enough. You need the ability to scale up and scale down. Consistency means you want a relational database, but you just cannot compromise on consistency of data. So for example, if you are a bank, the ordering of transactions at the time they are happening and for other transactions to see that order and later on, when you revisit those transactions has to be exactly the same. The credit and the debit in what order they happened has to be exactly the same. So that is something which Spanner offers. And yes, global customer base. And in the last but not the least, you are not developing your complete solution in isolation. The database service which you choose has to plug in with multiple other systems. What are those hooks which that database service provides to enable that integration? So those are some of the challenges which customers have told us and how we deliver on those. So let's look at some use cases and solution architectures. So Spanner is widely used in multiple verticals. These are just some of them. By no means this is an exhaustive list. Gaming, FinServ, healthcare, retail, technology, media and entertainment. And if you look through some of these use cases, like in case of gaming, user profile and winnings data is extremely common. Means why would somebody choose Spanner for that? Again, the gaming companies, you don't know when you are the next Pokemon Go or the next popular game. So they start small. They need that ability to scale. And with that, they want to show a consistent view of the data to all their global customers or global gaming community as people who are playing the games from North America and Korea and Japan and all the places they are playing it together. So you provide that unified experience and Spanner can enable that. In terms of financial services, again, there's online banking solutions which are built on Spanner, ledgers, user account data. We are going to talk more about online banking and some of those other use cases. Healthcare, we have companies who have built complete electronic medical records on Spanner because they were just struggling with maintaining like a deployment with, in this case, Oracle databases in each one of their clinics. So they decided that it's just becoming unmanageable. So for those thousands of clinics, they decided to set up a single Spanner instance with extremely high availability and combine and consolidate and leverage the power of data along with providing a better user experience for their customers. Retail, Spanner is being used by world's largest retailers, like Walmart is using Spanner now for a number of their use cases. And there are very common use cases like pricing, inventory management, gift cards, and supply chain management. Means technology, we have global companies which are using Spanner, and media and entertainment. There's a number of companies which are using it for catalog metadata, digital rights management, and a whole bunch of other things. So we won't have the time to dig into each one of these use cases in detail, but I'll touch on these three verticals and a use case each in each one of them. So let's start with the FSI, retail banking solution, as I was talking about it. And by the way, this Spanner is now used by some of the largest banks in the world. But what are they really looking for in terms of retail banking? Well, they need consistency and geographical distribution. As I talked about previously, you cannot compromise if you are a bank in terms of the consistency of the data, in terms of ordering of the transactions and all that. Spanner works for them because of that. They need that very high uptime. Again, they want that RPO 0. In addition to that, they want that protection, which point-in-time recovery now offers for a operator error to provide that RPO 0 capability, because losing transactions means losing money. In terms of performance and scalability, yes, they go through seasonal events as well, so they need to be ability to scale up and scale down. There are peak patterns typically around holiday events and everything, so they have to manage that. And then last but not the least, everybody wants predictable cost and elastic scale. So this slide just shows like a sample solution architecture. As I mentioned previously, as part of the technical challenges, customers are building complete solutions, and Spanner plays the OLTP part of it, but it definitely interfaces with a lot of other systems. One thing to note over here in this rectangle is Kubernetes along with Spanner. Now, this is a very common use case and very typical. So GKE working with Spanner, because you can seamlessly scale your compute along with your database, is a very common design pattern and something which we oftenly see customers using. You can see the omni-channel access to that same data via mobile, web, voice, and everything. And then you can see downstream systems getting the data based on the transactions which are happening, like analytical warehouses and everything, like BigQuery, cloud storage, data catalog, getting updated as the data is changing. So all this is enabled through multiple integrations which Spanner provides, but the core value prop is that high uptime, that scalability, that geographical presence, which customers are able to achieve by using Spanner. Okay, so let's talk about our omni-channel retail customer use case. So again, if you are a retailer like Walmart, you are looking for extreme performance and scalability. Means it's very easy for you on a Black Friday to receive millions and millions of requests, and your inventory is limited, so it has to be extremely consistent, and you need to be able to service those requests and do those transactions. So performance and scalability is extremely critical. Single source of truth, and this is even was true in the previous slide as you saw. But in case of retail, it's even more critical. Like these days, in addition to mobile and web, you are shopping from your Google Home and those kind of other devices as well. So providing a consistent view of data for a retailer is extremely critical. That means more queries, ability for multiple systems to connect to your database service. Consistency, again, availability. As I mentioned previously, the cost of downtime is high. We have retailers who have told us, like, if there's an hour of downtime during BFC, Black Friday, Cyber Monday sales, it will result in single-digit millions in some cases to triple-digit millions in some certain other cases. So I won't go into the specifics who we are talking about here, but the cost of downtime is high. SQL, this is very typical. We have seen in retail customers that they need SQL, ability to construct schemas. The staff is more familiar, so hence a relational database is needed. So this is a very simple use case, definitely not the Walmart use case, but this is like a retailer who was getting all this pricing data from external sources. They were ingesting that pricing data in cloud storage bucket. And then there was a Kubernetes service which they were running, which was loading that data in a Spanner instance. And then typical to omnichannel retailing, there were multiple services which were through this pricing API, which were reading that data about pricing information for that SKUs which were uploaded. And that's how Spanner was able to ingest all that data as well as provide a consistent view of the data in real time with that high read throughput. So fairly typical use case you will see in case of a retail. Now let's talk about gaming. Gaming, Spanner, if you talk about scale and you talk about high uptime and consistency, these are the three attributes which every gaming workload would need. Spanner meets all three of them. That's why Spanner is extremely popular in the gaming vertical. And we have some of the biggest game development companies in North Korea, in Japan, and now in Korea as well, who are developing games on Spanner. So first and foremost is the management. So we have a number of customers who are using MySQL historically, and sharding of MySQL is a pain. And especially, as I mentioned, you don't want to be re-architecting your app when you are popular, because when you are a game developer, if the game really becomes popular, you want to be servicing your gaming communities and rather than re-architecting and taking a downtime. So in Spanner, management, availability, and scalability wise, you architect your schema right, and you can scale from a single node to thousands or hundreds of thousands of nodes. And again, cost is an important thing. You want to be paying for what you are using, and there's literally no downtime. So I think Spanner works really well. In fact, in this particular customer case, there was a customer who was using 200 MySQL instances, which required 2 million reads per second, 400 writes per second, and they were doing that themselves. They switched to using a 600 node Spanner instance, regional Spanner instance in this case. And we did the TCO analysis with them. Spanner came out to be 3.5 times cheaper than that managed MySQL instance which they were using. So again, something, please let us know how we can be of help, but this is something to keep in mind. Again, just to summarize, customers find a lot of benefit with the scalability, which is automated because of the automated sharding, availability which Spanner provides. You can get to production much faster. In fact, ShareChat, which is one of our top customers out of India, they presented and they literally were able to get one of their apps into production within a week. So again, something which Spanner enables you to do because of the managed experience, and once you are familiar with it, it's very easy to get up and going. In terms of administration, we are talking about zero operations. Means you don't have to worry about upgrades, applying security patches, and worrying about those kind of things. You can focus on building your business logic, and rest we'll take care of. No downtimes, we already talked about that. And in terms of cost and providing you the right price performance, you will only pay for what you use. So that is the good thing, and you can scale up your instance, scale down. Okay, so finally, let's talk about migration to Cloud Spanner. So why are customers migrating to Spanner and from where? So they are migrating from a whole bunch of places like MySQL, Postgres. Again, sharding is a challenge. Non-zero RPO, RTO. Oracle, I don't have to speak much over there, but complex licensing, administration. Aurora, a number of our gaming customers migrated from MySQL Aurora onto Spanner, especially because of the scaling challenges which they have. downtime and everything. DynamoDB, again, ShareChat migrated from DynamoDB example, for example. It's a non-relational database, does not have strongly consistent global indexes, limited transaction support. And a number of our customers are coming from Cassandra exactly for the same reasons, pretty much. Now, how do you migrate? What are those migration steps to Spanner? So first and foremost is the assessment phase. You have to assess whether Spanner is the right choice for you. Second is you do a proof of concept based on what your application is and how it will fit on Spanner. Third is the design and implementation phase, which includes schema migration, data migration, and application migration. Then you are going to do some testing and a lot of testing and dry runs. And finally, it's the actual migration. So regardless of which database you are migrating from, these steps more or less remain the same. But having said that, every migration is different. Means there might be some new thing which you will encounter in migrating your second app versus the first one. So you have to play it as you go. Now, in terms of assessment, is Spanner a good choice? Means you need to evaluate what features are you looking for in terms of Spanner. Like, are you using what types you are using in Postgres MySQL, for example, and indexes, queries. Are you using auto increment or sequences? How do they map to Spanner? Means monotonically increasing auto incremental sequences and keys don't work well with distributed databases. It's just you won't be benefiting from the distributed nature of the databases. All the writes are coming to a single shard. So those are some of those things which you need to assess and see how you are going to transform your application. What kind of drivers you need, ORMs, and first and foremost, you need to understand the benefits which Spanner provide. Are they truly relevant for you? Like the scalability, the managed experience, the availability. We have a tool called as HarborBridge, which is hosted on cloudspannerecosystem.dev. That is a tool which will do that schema assessment and actually do small migrations for you as well. I welcome you to check it out for MySQL and Postgres MySQL. It generates an assessment report actually. Then you do a proof of concept. The most important thing for proof of concept is to basically have the key performance indicators or the exit criteria for POC to be defined. Then you will scope out what are your biggest risks in terms of this migration. You will be able to do your sizing estimate because Spanner is a relational database. It depends on what kind of schema and queries you are running of what you will be able to achieve. So that's basically in the proof of concept phase. Again, HarborBridge can help you over there as well. And then finally, in the design and implementation phase, you have schema migration, which is about types, columns, primary keys. What are the query performance you want to achieve? Do you want to use interleaved tables or foreign keys? Interleaved tables provide you a better relational database integrity, referential integrity constraint, because if you are able to do parent-child relationships in comparison to foreign keys, but foreign keys is just more flexible. Then you finally do assess the data migration, there are three models in which you can do data migration. Basically, you can stop and copy the database. It's the most simple approach, but requires downtime. The zero downtime approach is you can do an initial load, basically take a dump, load it into Spanner, and then you continue to stream changes until you catch up, and then you basically switch over your app. And then there's this dual write approach, which a number of customers use, which is flexible. It does dual writes to both your source database and destination, in this case Spanner, but sometimes architecting that might be a little bit tricky. And then you do application migration, which includes code assessment and code changes. Then finally, can't stress enough on testing. You should test the traffic, should be realistic, representative of your production data. And then as you learn more, you redesign, re-implement, and do more testing. And finally is the actual migration. You move the data, and it might be over a certain amount of time, but it can be a longer process. And basically, you go through that process, you complete that migration, And that's how you achieve it. I think this is it. Thanks a lot for your time. I know we covered a lot of content, but if you have any questions, feel free to connect with the GCP representatives, and we'll be happy to get in touch with you. Thank you.